All right, I have three, count them, three important warnings about conservation of momentum that I want to call to your attention. The first one that I want to call to your attention has to do with watching your signs. So I have these adorable warning signs, and my first warning sign is about signs. So watch your signs. Oops, watch your signs. By that I mean uh, you need to be careful that you're paying attention to what direction your velocities are and realizing that if the sign changed, the momentum just changed by a significant amount. So I have an example right here with throwing a bouncy ball at a wall and throwing a teddy bear at the wall. We'll imagine that we're throwing them the exact same speed, and we'll imagine that they're the exact same mass, which that's not too hard to think about. Uh, Teddy bears are big and fluffy, and balls tend to be smaller. I mean, there's a density issue, but their mass might be the same. So if I threw them both at the wall with the same initial speed, they're going to have the same initial momentum. But then the bouncy ball hits the wall and bounces off, and the teddy bear is just going to be like, and slide down. If we're asking the question, well, what happened? Which one of these had the biggest change of momentum? Which one of these had the biggest impulse? Which one of these experienced the greatest force from the wall? All of these things require us paying really close attention to the signs. So I'm going to assume that they both have the mass m, and they're both starting with v, a velocity of v. That means their momentum at the beginning is mv. That ball then hits the wall and it bounces off. Let's say that it bounces off with almost exactly the same speed it came in with. But what's changed here is that the velocity switched directions. So this doesn't have a velocity of v, it has a velocity of negative v. So that's negative mv for the momentum after. The momentum didn't stay the same, the momentum switched directions. In fact, we have a change of momentum here of negative 2mv. We took away that mv, and then there was another minus 2 mv. So that was a significant change. The teddy bear, on the other hand, went from mv to 0, which was only a change of mv. There was a bigger change of momentum on the bouncy ball. There was a bigger impulse on the bouncy ball. There was a bigger force on the bouncy ball. If you ever are offered the choice between slamming into a wall and sliding down dramatically or bouncing off of a wall, you're much better off hitting it and sadly sliding down. That will be a smaller change in momentum and likely less force acting on you. So watch your signs, because the most common thing that students say is that ball experienced no impulse because the momentum was the same before and after. And that's wrong, but it's a very common mistake. Our next thing that I want you guys to watch out for is I want you guys to watch out. Again, this is a sign error, but this is a different sign error. This is our kinetic energy signs. So with momentum, we can have positive and negative. We can't have positive and negative kinetic energy. So my warning here is don't subtract kinetic energy. For example, this here has mv and negative mv for momentum for a grand total of no momentum. But it has 1/2 mv squared and 1/2 m times negative v squared kinetic energy. When I square that negative sign, I'm going to end up with 1/2 plus 1/2 mv squared, or a total of mv squared. I have kinetic energy. It doesn't subtract. Don't make the mistake of saying there's 0 kinetic energy at the end. That's definitely not true. So be careful. You should always add your kinetic energies just to be safe. Just ignore any negative signs. The part of where this comes up really often is if you plug this into a calculator as something like 1 times, I don't know, a mass of 5 times negative 5 squared, your calculator is not smart enough to realize that that negative sign should apply before you square it. Instead, it will see that negative sign and say, oh, you want me to do that after? I'll do that after. And it would give you a negative value. So be careful with your kinetic energy. Make sure that you always get positive values and you add them together. the last warning is that I want you guys to think about your closed systems. We really want to be using this pretty much only for collisions. So if, like I have on this problem off to the right, we have this problem right here. We have one object hitting another object and they stick together and then they move together and the problem asks what their maximum height is. You can use conservation of momentum, and you need to use conservation of momentum for when they hit, but you won't be able to use conservation of momentum to figure out their final height, because their final height requires the outside force of gravity to be acting on it. And the problem gets, it's not solvable using conservation of momentum. So make sure that you make the deliberate choice to use conservation of momentum when we have collisions, but you don't try to use it for the entire problem, because it's usually not appropriate for the entire problem. It's usually a step within a broader problem. So those are the 3 big warnings, 3 big tips that I have for you guys in momentum. I hope they help. See ya.